One more thing that we'll look at is the effect of signal shifts. So observe that the stride we used in our autoencoder. The stride corresponds to the down and up sampling rate of the corresponding filter bank. This sampling together with the convolution has the effect of processing the signal in blocks of size of the stride. If we now shift our input signal by prepending the number of stride zeros at the beginning, hence delaying it by stride samples, we will get the same blocks just one block later. On the other hand, if we prepend a number of zeros which is not an integer multiple of the stride, the blocks will look different, and hence the result will look different, not just shifted. So for this example, we are going to test the trained autoencoder first with 100 zeros added at the beginning of the training signal. And we are using this constant pad 1D, so we are inserting 100 zeros on the beginning of this training. So we are giving a shift of 100 zeros, and then we are making predictions from this shifted input signal, and we can listen to it. We notice that the output appears really noisy. We will now shift not by 100, but by 1024. And this is related to the exact same number of strides. So we are now in this situation that we are shifting the input signal by prepending the number of stride zeros at the beginning, that is delaying it by stride number of samples. And this we are going to also listen. So let's compare. So pay attention now that we are using the same X train. So both use the X train, but first we are shifting by 100, and here we are shifting by 1024. And when we use the 1024, which is the same number as the stride, we notice that the noise added is much less. So we clearly see the effect of having these blocks starting on different points, how it affects the output of our model. So this behavior might be desired if a certain position or timing is important, but often is not desired. A straightforward remedy is to set stride, for example, with 1, but this leads to a much higher computational complexity for training and test or inference. As a compromise, we reduce the stride to a small value. For instance, for example, a stride equals to 16, and this has a lower complexity and not much audible shift sensitivity. And you can experiment if change in our model, you change the stride value both in the encoder and both on the decoder. So when we define our model here, if you change the stride values here, and you can change to two different values, for example 16, and then you compare and see what happens.